Hi everyone, welcome to Undoubtme. Here we are back with one very good question of series and parallel combination of resistors. And as you can see in the question, they have given a circuit. They are asking us equivalent resistors, equivalent resistance of the circuit and current through the circuit, that is total current, and find current through each individual resistor. So basically we need to find R equivalent, we need to find full current, and then we need to find readings of ammeter A1, A2 and A3. Okay, reading A1 will be the current of whole circuit, A2 and A3 will be different because over there at this branch the current will get distributed. How we have to execute this? Let us see the working. So here we are. First we'll start with finding equivalent resistance of R2 and R3. So I can say this thing as R23, which is equivalent of R2 and R3. That will be equal to 1 over 180 plus 1 over 220. On calculation, this comes out to be 1 over 99. You can use calculator or whichever you want to do. I'm just showing you the answer part. So on further calculation, the value of R23 is 99 ohms. Now the net equivalent resistance of the circuit will be 110 plus 99, that is 209, and from here we can get net current. The total current of the circuit will be equal to, we will be using V is equal to IR. So using that, total current will be equal to V by R. V is 24 and net resistance is 209. On calculation, this will give me 0.11 ampere. Now till here we are done with equivalent resistance, which is 209. That was the first thing they were asking. Then total current, which is 0.11. And now we have to find current in individual branch. For that, we will find voltage across branch R1. Okay, let us do that. So voltage across R1 is, let's say, V1. And that will be equal to IR1. Okay, I'm using simple V is equal to IR. I is the net current because this is connected in series. So net current is 0.11 times 110, and on calculation this comes out to be 12.6 volts. Now I've got V1. Total voltage of R1 and R2 R3 combined will be equal to 24, the total voltage. Okay, so V1 we have already got. I can get the voltage of R2 R3 combined, which I am calling it as V23, and that will be total minus 12.6. that will come out to be 11.4. Now 11.4 volt is the voltage across these two terminals. Let them be P and Q. You can see that R2 and R3 are connected across the same terminals PQ, and those are the points which can give me the reading of A2 and A3. So finally, I2 is the current for ammeter A2. That will be equal to the voltage over that resistance 180, and that will be 0.063. And for I3, I'll do the same calculation, but 11.4 is divided by 220 this time, and I will get 0.052 ampere. So this finishes my overall question. In this, if you review it again, we have found equivalent resistance, we have found total current, then we distributed that current across junction PQ, and accordingly the readings of ammeter A2 is 0.063 and ammeter A3 will be 0.052. I hope that all steps in the calculation is clear. You have to follow all steps if you are writing any theoretical exam, any board.